Assalamualaikum, very good evening to all. So basically, even though we just entered chapter 4 today, but we already at slide, we already finished slide. Just now we did this one, example 14. Okay, and basically, if you look at example page 14, okay, as that example, and then this one example number 2. Okay, so basically if you go through, okay, try to go through and understand the solution, and because the solution is in the slide, that's the reason why I want you to print out the notes. Okay, so of course printing the note is one thing, but try to derive it on your own is another thing. Okay, don't just read it. Okay, so basically for this example is that you are given XD equivalent to E minus AT UT. So if you're using Fourier transform table, you can directly actually get the Fourier transform table. So if you look at this is solution. So basically you use the xj omega, okay, substitute it, and then in the end you actually solve that xj omega for this E minus T is 1 over aj omega. So basically if you look at the Fourier transform table, where is E minus ATUT? Is this one, and if you see here, E minus AT is exponential and it's multiplied by UT, and that's the reason why this signal is starting from 0 until infinity. Okay, because we know if you have UT is a step multiplied by any signal, so it's going to multiply it, so you have the exponential up until infinity. Okay, so for this you may directly use the Fourier transform table. So you need to actually check which equation that you're going to use. So your equation is E minus AT, which is this one. Okay, so the Fourier transform equation that you need to use is this. So basically you already proved this. So example 2 is to actually prove that as an engineering student, you know that where did the equation came from. Okay, this is an example when you have a modulus for the t value. So you have E minus AT. So basically you have both sides exponential, left and right. And you prove it also for that. So you can see that it's at this, okay, E minus AT, you use this equation 2a over a squared over or plus omega squared. So you prove it over here. So just go through the solution. Okay, in final exam, of course, there's you're not going to use equation xj omega, this equation, because you are going to apply directly Fourier transform table. But as an engineering student, you need to know where did the table came from. Okay. Okay, and another example here, also I won't go through it because it's going to be long. So if example you're given a cos sine wave, okay, so how to actually get the Fourier transform is that you go through the solution, and in the end you actually get two sync value left and right. Okay, so go through that if you want. Okay, additional knowledge. So what we plan to do continue today is tonight is on page 31. Okay, so we already at page 31. So basically after we finish all the transformation, basically transformation that you're going to use in this Fourier transform is scaling factor, shifting, and also what is it, linearity. Okay, 3 different properties. Okay, so if you look at slide 31, is just repeating of the previous slide, because this is just a partition, a partition between, like for example, finish class, this end of this class, tomorrow we start with another slot. So this one is just repeating of the previous class. Same thing if you go through, we did this morning. Okay, this morning. Okay, and in this is same thing. Okay, this slide shows the same thing, just that additionally is I show you in this how to plot the sync value. Okay, after you use the Fourier transform, you get for example, for this signal, okay, for this signal, if the value is 1/2, okay, so the sync value is going to be a larger period, okay, so the larger the rectangular signal, then the sync value is going to be actually shortened, okay. So just to understand that effect of the expanding the rectangular signal to the sync plotting, okay. So for today, we are going to focus on this slide number 34, okay. So slide number 34 is basically the property of Fourier transform. So basically, we are going to apply what you have learned in chapter 1. Chapter 1, you have learned on scaling factor, okay, scaling factor, shifting of a signal, and linearity. Okay, so we go one by one. So first one is, in this page is, we are going to do example number 1. So basically, okay, let's just screenshot this. I'm going to open whiteboard. Yeah, so quiet. So for some reason, there's like a macam nobody inside the library. Okay. Alright. So in order for you guys to understand scaling factor, okay, for scaling factor, shifting and linearity, you need to use general equation for Fourier transform, or for the rectangular form. So let's just start with, let's say this is for properties, scaling. Okay, so general equation for rectangular, okay, this one is important. Okay, important for all the three properties: scaling, shifting, and linearity. So basically, for the general equation, okay, so I'm going to write here. The font size is okay at the back. Is it okay? Okay. General equation or signal lah, basically is at t equal to 1. So if you were to draw t equal to 1, how does the graph look like? So you have 0, and then you have t over 2 and minus t over 2. Correct? So you have the signal like this. Okay? And then the amplitude is, okay, so this is xt. This is t. Amplitude will be 1. Okay? So this, so remember, every time I say, okay, refer to the general equation for the rectangular. So means that t equal to a, and another one that you need to take note is that a equal to 1. Okay. Or normally, you can do that, but normally I would just say that t equal to 1 only. Okay, general equation. Okay, so you can put that a if you want. Okay, so for scaling factor, if you look at the Fourier continuous time Fourier series table, okay, this table is important for you to print out. Okay, so that you get familiar with it, because in final exam you're given the same table. So if you're familiar with it, it's easy for you to actually answer it later on. Okay, so familiarize with it. So for the property, you need to scroll down to the second page. Okay, second page stated the property of Fourier transform. Okay, so for the scaling, okay, scaling, where is it? No, yeah, 4.3.5, a bit slow. Okay, so here is the, okay, here, this one. So you have time scaling, property scaling. So you basically have this one. Okay, so this is the Fourier transform equation for it. Okay, so let's just write it here. Okay, so based on the equation, you have f j omega, or sometimes you can just directly omit j for in this. Okay, so I'm going to write exactly like the table. So FAT equivalent to what? So the F omega is equivalent to 1 over A. Okay, F omega over A. Okay. Okay, so since they are using F over there, so I'm going to change this signal, okay, and name it as FT, right? So that you don't get confused, but it's the same thing. If it's XT, then you basically change X to F and so on. Okay, so this is the first thing. Okay, so based on this, if you look at the example, okay, it says there that find, okay, find the Fourier transform for this equation, okay, xt, okay, xt. So xt is a bit different from the general equation. So what's the difference? What's the difference? If you look at here, this is the question. The question is that you need to use this xt and find the scaling factor in this term. Okay, so just draw it out first. 0 minus t over 4, t over 4. Okay, it is given by amplitude is 1. Okay, so this is signal xt. Okay, in order for you to do this, you need to write out first what is the value of t and what is the value of a. So what's t? T equal to what? T. 1 over 2. Okay, correct. So 1 over 2, A is 1. Okay, so in this case is that basically what you want to do is that you want to compare, okay, with the general equation over here. Okay, general equation. So basically if you know that this signal is actually based referring to the general equation, this one on top, the signal is, the period is 1 over 2, which is compressed. Okay, so what's the scaling factor there? Therefore, scaling factor A equal to, what's scaling factor? If you have 1, the general equation, if it's shortened to 2, 1 over 2, so what's the scaling factor? 2 lah. 2 lah. So A is the scaling factor. So therefore, scaling factor A is equivalent to 2. Okay, remember again chapter 1. This is really important. That's why chapter 1 is important to understand scaling factor. Compress and expand. Compress is what? When you have 2 times, right? 2 times. So basically, scaling factor is A lah. In this Fourier transform, we call it as A. So A equal to 2. Okay. So based on that, what you need to do is that first, okay, we are going to use the general equation. So if you look at here, this is, okay, if you look at this equation, A is the scaling factor. Okay, so A is scaling factor. Okay, so therefore, if you look at the equation, the Fourier transform table is given by 1 over A. Okay, F omega over A. So what you need to do is that first you need to find F omega. Okay, so first step, if you're given a signal that have scaling factor in compared to the general equation, so you need to find the F omega for the general t equal to 1. So find F omega for, okay, this is step 1 so that you don't get confused. So step 1. Okay. Find F omega for t equal to 1. Means that general signal or equation. Okay, so remember this morning, what was the equation if you want to convert from ft to f omega? Okay, for rectangular, because this is rectangular signal, right? Okay, so identify first lah, because since this is rectangular signal, so you're going to use the Fourier transform. So to answer this, you need to use rectangular Fourier transform. Okay, first one, and then also the scaling factor. Okay, so what was the equation for that? So F omega equivalent to A, guys, what is it? A T sinc omega T over 2, right? Okay, so based on this, substitute the value that you have for the general equation. So general equation, the value that you need to substitute is, do you have A in the general equation? Yes, right? So basically, and if you want to substitute that, make sure that you follow what the value for A over here. Okay, so because this question, the A is given 1, then you're going to substitute A equal to 1 lah. If the question, the amplitude is given 2, then you're going to substitute 2. Okay, for this case, since it's A equal to 1, then you just write at the side here, for the general equation, T equal to 1, then and A equal to 1 also. Okay, so we are going to substitute that. So A equal to 1, T equal to 1, okay, T equal to 1. 1 sinc omega 1 over 2. Right? So you get sinc lah. Okay. You get sinc omega over 2. Okay? So remember, this is for the T equal to, for the general equation. We haven't done the scaling factor yet. Okay, so now the next step, step number 2. Okay, step number 2. Okay, using using f omega for scaling property. Okay, scaling property. Okay, find x omega lah. So the original equation was x omega, right? So let's just write out again the equation for scaling just now. So scaling factor property. What was the equation? F omega equivalent to 1 over A F omega over A. Okay. So right now, what does it mean? Okay, so what does it mean by this? Why there are two F omega and F omega? So the first one is for scaling property F omega, because you're trying to find out by using the properties. Okay, so this in the inner equation you have F omega. Okay, this one F omega. So basically this F omega is referring to this one based on the general equation. Understand? So basically you're going to write it in terms of, okay, so let's just substitute it, and you based on the equation you already know what is the A value. A equal to 2, right? Okay, so A equal to 2. Now we just substitute the value. So F omega equivalent to 1 over 2. Okay, so for this case is that F omega, what is the transformation? Sinc omega over A. Okay, so sinc, okay, omega over omega over 2, omega over 2, okay, and then you are going to multiply by 1 over A, right? 1 over A is 1 over 2. So means that this part, what it means that you're going to write sinc, okay, omega over 2 is the original omega over 2 over A, like this. Okay, and based on that I substitute the value. So A is 2, right? So you get this one. Okay, if you can imagine it, if you try to actually substitute it, okay, and then you will get the answer 1 over 2 sinc omega over 4. Okay, so this is answer if you are using scaling property. But this morning we did a much more easier way, right? Without even using scaling property. Okay, whereby what was the option? Okay, or so this is according to your call it choice lah, basically, because in final exam you don't actually tell you which property to use, okay, or okay, according to this morning equation, what was it for rectangular? So rectangular, okay, for F omega, okay, so you have what? If you have rectangular, the equation become F omega equivalent to AT sinc omega T over 2. Okay. So this is if we do not do any scaling property, but directly looking at the rectangular signal. Okay. So directly looking at the rectangular signal, so let me just draw it very fast. So you have minus t over 4, okay, t over 4, like this, and 1, okay. So based on this, what is A? 1. So A equal to 1. What is T? 1 over 2. So we directly substitute into the equation. Okay, so A is 1, T is 1 over 2, T is 1 over 2. Okay, so what do you get? 1 over 2 sec omega over 4. Why we do this complicated way? But just to show that scaling factor lah. Okay, the scaling factor. How to use that properties in the Fourier transform. Because sometimes maybe the question just simply say that using the property of scaling, find a solution. Then you need to use the scaling property. Okay, so by doing this two method, you get the same answer. But of course, the second one is easier. Because directly looking at the rectangular signal, just find what is A, the amplitude, and just find what is T. And just substitute it. But in compare, if you were to use scaling factor, you need to find the general equation, which is based on T equal to 1. Which is easy also lah. Okay. Then after that, you need to find what is the scaling factor. Then just substitute it and you get the answer also. Okay. Why I'm doing this? Because for shifting property, you need to use this general equation first. Okay. And that's the reason why I'm teaching it also. So that directly we are going to use it. Okay. So any question? No? Okay. Good. I assume good. Okay. Right. Now we go to the second one. So this one is the first one just now. Same thing. You can go through it if you want. Okay. Second one is shifting. So property for shifting. If you look at this, let me just remove this. Okay. So the question is this one. They ask you to find the signal in frequency domain, which is given xt, find in frequency domain. Basically, you need to find what is x omega. And you see that, oh, you have a rectangular signal. Rectangular. But you know that if you are planning to use rectangular Fourier transform table by comparing it with the table, you need to make sure that the rectangular signal is in the center at 0 point. Okay, it means 0 point. Now it's being shifted. Shifted means that it should be here and it's shifted to the right side. So for this case is that you need to know that if shifting left or right, okay, means that the shifting value, we call it as T naught, is positive or negative. Okay, if it's shifting to the right, then the shifting value is positive. If to the left is negative. Okay, so let's do this example. Okay or not? Too fast or what? Guys? Okay. At the back there. Okay. Okay. So, for shifting, first step is the same as what we did in the previous example. So, you need to write out the general equation. So, do that first step. So, first step is, okay, step 1. Okay, general equation or signal, basically T equal to 1. So, draw it. Okay, so then so that you don't make the mistake. So, minus T over 2, T over 2, amplitude A, Okay. So based on that, what is the transformation? So you have rectangular. Okay. So you get F omega equivalent to AT sec omega T over 2. So let's just write what is A and T here. So what is A? A equal to? Before you write that A equal to what? Refer to the original question. Okay. Original question means that this one. Okay. In this question, what is the amplitude? 1. Okay, so 1. So basically, based on that, you're going to write amplitude is 1 and T is equal to, because general equation, then it's 1 also. So write it out. Okay, so you have 1, 1, sec omega 1 over 2. Okay, so you get same thing as the previous one. So I'm just going to write it out. Step number 1. Okay. Basically, I already refreshed just now. Okay, refresh how? I was so tired because from this morning, right? And then classes and then meeting and then so refresh. So my way of refresh is playing ping pong. So I was playing ping pong at the Masukan just now. And so you. So that's how I refresh lah. And so I don't know how you refresh because if I sleep, I go to sleep. Terus lah, eh? Okay, so right now finish writing. Okay, so after doing that, then next step is what? So you need to look at the property based on the Fourier transform table. So can you find the shifting, time shifting? Which one? This one, right? Time shifting. Okay, so time shifting, this one. So you have the x t minus tau. So basically, t minus t naught. So t naught is the shifting value. Okay, shifting value. And it's given by E minus J omega T naught X J omega. Okay, so let's do that. Step number 2. Okay, step number 2 is use shifting property. Okay, shifting properties. Oh, before that. Oh, before that, sorry, I forgot about one thing. Okay, the t value, okay. So if we are doing this way, then we are going to have another step lah, which is we need to do the scaling, but I think too long, So what we do is that we use the second method just now, which is directly. Remember? No, cannot remember. That's okay. We just open this. Okay, this one, the second one. Okay, you did this first one, which you need to do the general equation, then you do the scaling. Okay, or you can directly use the rectangular. For this case, because I'm going to emphasize on using the shifting only, so a quick way to get the answer is by doing this, right? Using this equation only. Of course, if you want to do the scaling, also can. Okay, which one you want to do? Which one? Yang cepat. Okay, yang cepat. Kita pala balik sikit yang ni. Padam je. I boleh padam lah. You tak tahu lah. I tak tahu you boleh padam ke tak. Boleh. Boleh padam. Jom padam. Padam. Okay. Okay, padam dulu sekejap. Sikit je padam. Erase it. In English is erase. Okay. Alright, okay. So, erase this. Okay. So, based on this, we are not going to use the general equation because then we need to have 3 steps. Okay, we are going directly to we are directly using the rectangular equation, Fourier transform equation. So what do you have? Okay. So what you need to do first is that we look at this. Okay, imagine that if the signal is in the center, so how does it look like? It will be like this, right? Because this is what? T equal to 2, right? So means that your signal in the center will be like this. Because you want to use rectangular form, So it become from -1 to 1. Okay? So based on that understanding, then you are going to draw this first one, means that rectangular f omega in the center. So you have -1 to 1. So based on this, t equal to 2 just now, and a equal to 1. Substitute it, so a equal to 1, t equal to 2, or sinc omega t equal to 2. Then you get 2 sinc omega. Okay, this one become 1. Okay. Right? Now, according to this shifting property just now, the equation, the shifting property is given by f omega, f x t x t minus t naught, okay, is given by f omega e minus j omega t naught, okay. So this is the shifting property based on this table. Okay, this table, this one. Any question ke? Ada yang tak faham? Dengar banyak cakap. President, your friend okay? Ayan? No, so far okay. Suresh, Abraham? Okay. Right. Now, okay. Okay. You have learned in chapter 1 previously, you learned chapter 1 kan. For example, if you have a shifting, okay, for example, step input ut. Okay. If you have ut minus 2, how does it look like? And that is going to shift to the right side, right? Okay, by 2. Become like this. Okay, so why I'm telling you this is, okay, you are going to actually compare this with this equation. Okay, so meaning that based on this understanding, what is your T naught value? T naught equal to what? If you compare directly, T naught equal to negative 2. Compare directly. Only in the bracket only, in bracket T minus T naught. So T naught equal to? Okay. So T naught equal to 2. Okay. Understand? So it means that if it's shifting to the left, then T naught equal to? Minus 2 lah. Where's the marker? I tak bawa marker lah pula. Ada marker? Bukan pemana marker tapi. Ada ke? Ada. Ada. Tu. Pemana marker ke apa? Boleh lah. So, for example lah. Example, maybe UT is confusing for you kan. So let's say you have signal, this signal, but we call it as xt. Okay. So this is 0. Okay. So let's say that you shift it to the to the right side. So basically you have like this, right? Okay. So shifting. So if this is 0 to 4, then it's going to be 2 to 6. So this signal you can write it as x t minus 2. Okay. And by comparing directly with this, okay, what do you get? So you get this value is t naught. Okay. Example, if the signal is like this, okay, minus 2 and 4, so and 2. Okay, so it means that this is shifted to the left side. Okay, so how do you write this signal? So x t plus 2. So if you were to compare with this one, okay, just now x t minus t naught. So for this case, therefore t naught equal to 2, right? For this case, you have x t minus t naught, but you write it as x t plus 2. So what do you have? Therefore, t naught equal to minus 2. Why minus 2? Substitute only lah. So basically, if we have t minus minus 2, you get x t plus 2. Same. Okay. Just to show that the shifting. Okay. Positive or negative is important. If you put it wrongly, then your final answer is wrong. Okay, based on that, now it's easy. Okay, because from this equation, okay, so you can basically therefore, okay, x t minus 2, substitute the value t naught. So t naught is 2. So you get f omega. Okay, so f omega is basically, in this case, is what? Is referring to this one. Okay, referring to the rectangular. Okay. Okay, so let's write out. So you have 2 sec omega, and then you have dot e minus j omega. T naught is 2. Okay. Therefore, the final answer for x omega, okay, x omega is equivalent to, you can write it as 2 sec omega if you want to separate it so that you don't get confused, e minus 2j omega. Okay.
So just for clarification, in the table it writes xj omega. So here it's just f omega, right?
Table. Which one?
The xj omega.
Mm-hmm.
That xj omega is just f omega.
Oh, yeah. Normally, according to table it's j omega, but I just lazy to write j. But normally, because other books, they write in terms of x omega. Some books is xj omega. So I just write it x omega only because we know that it's in frequency domain. Okay, so because lots of books have different way on writing the equation. Okay, so let's example lah, in your final exam later, maybe there are 2 types of table that you will receive. One is my table because I teach using different table. Another lecture they use the different table. Okay, but different table means that from different book basically. So refer to the one that I teach in class lah, so that you don't get confused. Okay, so there are 2 sets of table later on. Okay. Okay, so this one is okay, shifting. Okay, now we go to the interesting part, which is linearity. But before that, we take a break lah. Okay, we go to the last one of the property, which is linearity. The linearity. So basically, this one is an example of past year exam question, whereby you see that given ft. So in this question, they label as ft lah. So ft given by this signal. Okay, so you have the signal from -2 to 2, but have a different amplitude. Okay, for each part lah. Okay, how you are going to apply this is that, when you look at the question, you see that it looks like a rectangular, right? Okay, by having the knowledge of linearity, which is you learn in chapter 1. So linearity is that if you have 2 signal, A f1 plus A B f2, you can write it also in terms of Fourier transform, so which is linearly lah. So you have A f1 omega plus B f2. So A and B basically is the amplitude value. So A is different amplitude, B is different amplitude. Okay, so I think I skipped this slide. Why? It's not animation. Okay. So how you answer it is, okay, by knowing the linearity, so I write here 3 different options to answer it. It depends on how you look at it. Okay. So the first option, which is this first one, okay, means that you're going to have a rectangular with the period from -2 to 2 and amplitude 1. Okay, first signal. Okay, second signal that you can see is that like this lah. Okay, which is you have another signal then have the period from -1 to 1, and amplitude is 1. It's like a cake lah, basically. How do you actually make the tier cake? You have first tier, right? With the amplitude 1. And then second tier, amplitude 2. Then when you combine it linearly, then you actually build up the cake. Okay? So this is first answer, which is the easiest way. Because why? You can see that only involve directly using the rectangular equation, okay, for the continuous time Fourier transform. You can skip doing the scaling factor because it's too tedious. Okay, it means that you need to do 2 steps, but using directly rectangular equation, then you can get answer. Okay, second option, which is if you have more time lah, and then you just want to show off lah. Basically, kan, show off to me that you really understand this. Okay, so basically what you do is that you want to split it into 4 different period. So you have this rectangular from -1 to 1, which is t equal to 1, but have a shifting, which is originally was here, it shift to this part. Okay, so imagine that you need to do a shifting for this. And then second, also same thing, rectangular with the period 1, and also it was being shifted, okay, by 0.5, right? And then the same thing, all shifted lah, basically. So if you have lots of time, then you can do that. Means that find the rectangular and do a shifting, everything shifting, and just combine everything. Okay. Last one is almost similar to this, but you are more -1 step. Basically, this is 2 steps, this is 4 steps, this is only 3 steps. So basically, you get this one plus this one, because why? You have from period -1 to 1, amplitude is the same. Okay, 2, and then you combine another one. So 3 steps. So what I'm going to show, of course, the easiest step lah. Okay, easiest step. Okay, so let's do that. Okay, how we are going to go about this solution, So draw first. -1, -2, 1, 2, amplitude 1. Okay, 1, sorry, not 1, 2, 2 and 1, 2 and 1. So this is given by FT. Okay, so how you do it is you're going to split this FT, okay, solution, okay, FT equal to F1T plus F2T. Okay, so what does it mean? So I'm going to, like what you have done before. So basically, this is 1, or we call this is 1 and this is 2. Okay, up to you which one you want to label. I'm going to label the down part is F1T and second one is F2T. Okay, this one. Okay, so based on that, we need to draw out first. I'm going to draw on the left side, this side. Okay, so F1, 0, -2, -2, amplitude 1. This is F1T. Okay. Another one is you have F2T. -1, 1, amplitude 1. F2T. Okay. Anyone do not understand why F2T is amplitude 1, not 2? Anyone do not understand why it's like that? Okay. So we go back to the chapter 1, which is, let's say based on the drawing that I put just now, F1, F1T, 0, minus 1, minus 2, 1, okay, amplitude 1, okay. Then in parallel, I'm going to write 0 and minus 1, 1. Okay, you ready to finish? Maybe yes, for the rest. Okay, so this is 1, 1, 1, 1. F2T, amplitude, based on what I draw, is amplitude 1, 1, 1. Okay, so I write just now, Ft equal to F1T plus F2T. Remember, in chapter 1, what does it mean by that? What does it mean? Amplitude at E. Like doing the even signal, right? So T 0 minus 1 minus 2 1 2. Really, by like 5 seconds only, 10 seconds. Okay, so let's look at minus 2. Minus 3, of course, there's no value, right? So minus 3 minus 3, so minus 3 is 0. Okay? And minus 2, 1 plus 0. 1. Okay? 1 plus 1. 2. 1 plus 1, 2. And then you have 1 plus 0.
Then 1.
Nah, I also do mistake kan. Okay. So 1 plus 1, 1. 1 plus 0. Sorry, 1 plus 1. 1 plus 1, 2. 1 plus 0, 1. Okay, next. 1 plus 1, 2. 1 plus 1, ulang. Basically, there's no. Sorry. 1 plus 1, another one is 1 plus 1. 1 plus 0, 1. 1 plus 0, 1. 1 and 0 plus 0, 0. Does it look like that? Okay. So basically you separate it into this one and then you add it up, you will get a value there. Okay. Takut so scared for you guys for final Okay, so after this, so do you think that it's easy to answer this right now? Okay, what you need to do, you need to find what is F omega, right? So find what is F1 omega. This one find what is F2 omega. Alright? So let's directly do it. So we write it as F1 omega equal to what? What's the equation? So wait, I directly write first. Since we know that it is a rectangular signal. Okay, we use rectangular T. Okay, which is what? F omega equal to what? What's the equation? AT sinc omega T over 2. Okay, so this is the equation. So basically, okay, we need to find out for F1T what is A and what is T. So write up first, what is A value? A equal to 1, T 4. From here to here, right? So basically you have 2 and plus 2, you have 4. So T equal to 4. Okay, this is for F1 omega. Okay, F2 omega, same thing. You need to list out first what is A and T. So A, what is the value? 1, right? 1. Haziq? Haziq? Okay. Okay, what is A? Ha? Betul, A. Equal to 1. Kenapa? Okay, graf satu So, A 1. T apa, Haziq? 2. Ni So, 2 T equal to 2. Okay. So, now we can write the equation for F1 omega. Okay, F1 omega, A is 1. Multiplied by T equal to 4. Sink omega T equal to 4 over 2. So you have F1 omega equal to 4 sink 2 omega 2 omega. Betul tak? Okay, so next, try to do for F2. F2 omega. Okay. What's the answer? So A is 1. T is 2 sink omega 2 over 2. So you get 2 sink omega. Okay. Therefore, F omega equal to F1 omega plus F2 omega. Okay. So you just substitute the value lah. So value for F1 is here, which is this one. Okay. And F2 is this one. This one. Okay. So you write it as 4 sink 2 omega plus 2 sink omega. Okay, so this is the answer. Oh yeah, we do more exercise, extra. Maybe one more or two more. Okay. We try to cram everything so that I'm planning that by next week we finish Fourier transform. Okay, on Monday we finish, because if we can finish this, because later we do this example and next week we start with the circuit analysis using Fourier transform, and that will be last for chapter 4. Then we can directly go to Z transform. Okay, so if we finish early, then we can do a bit of revision. Okay, so okay, now for this one, even and odd. Okay, basically it's the same concept. Okay, so even and odd is basically the reverse of it, but I'm not going to emphasize on this. If you want to do try it out, you can try it out. So basically exercise 1 we have done it in the example. Okay, and the exercise 2 also you have done it in example, have the shifting. Okay, so you can just try to do the exercise. Okay, and for this exercise 3 is that a combination of even and odd signal. So you can try to do it, but it's not compulsory lah, because final not coming out. Okay, so we just ignore it for a while. Okay, and look at this one example past year. So it's almost similar like that, but you have 3-tier cake lah. So tambah je lah. Tambah je. Another one, F3. Okay. Even this one, student cannot answer. Don't know why. Past year lah kan. Okay. Okay, tier cake. And this one example also, same thing. Okay. Alright, now we go to convolution. Again lah, chapter 2, what the, what? Why? We already did convolution. Okay, so convolution, basically, in Fourier transform, if you remember what you did in Fourier series, in convolution, chapter 2, okay, chapter 2, you have convolution integral. Okay, for this time. And then you have another one is convolution sum for discrete time. And what we did for the whole exercise since this morning was focusing on continuous time. Okay, because I'm not going to go discrete time, not going out for final exam, so we don't need to cover it. Okay, but if you want to go, you can look at my notes. We have that also covered. Because last time the cohort, some question was discrete time. So convolution integral. So, and in this case is that if you look at this, okay, plot diagram, plot diagram. If you remember, chapter come to kita. Nak share ke depan boleh kamu find. So we have PhD and HT we call it as impulse response in chapter 2. Okay? Impulse response. It doesn't mean the impulse like this. The name for HT in convolution, name it as impulse response. Okay, if you have HT, you have input, right? X, C, and you have Y, P. In control, normally this one we label it as T, right? Okay, but that one control lah. In signal, we use HT. Okay, so this one is time domain. So if you convert it to frequency domain, it looks the same. Okay, H omega, input X become X omega, output become Y omega. In time domain, chapter 2, what was the method that you use for continuous time?
Graphical.
Convolution integral, right? So you basically did X, E, integrate with, H, T. So you do the convolution integral, which is like a lot of work, right? So in frequency domain is much more easier. Much more easier. You don't need to do all the shifting or whatever and so on. So basically you have Y omega is basically H omega times X omega. So you have X omega times H omega. It's similar like if you learn Laplace. Okay? H S Y S X S. If you have taken control subject. Okay? Control subject. So how do you write this equation YS? YS equal to XS times HS. Okay? And then somewhere in the middle here you use partial fraction. Also for Fourier transform. Okay? Same thing. Okay? So, and then if you look at this, okay, this one is in time domain, frequency domain. And basically, after you get your answer in frequency domain, so normally the question will ask, find the answer Y, output of Y in frequency and time domain. So basically you need to reverse it back. So to find it in frequency domain, you use Fourier transform. To get it in time domain, you use inverse Fourier transform. Similarly, like Laplace, you use Laplace to convert from HT to Laplace. Okay, and then to reverse back, you use the inverse Laplace. Okay, directly use table. Okay, so let's skip that. This one is just explanation. So this one is explanation of the convolution integral before. Okay, this one already explained there on the whiteboard. Okay, now we do this. Wait there. Why become like this Oh, tertarik Okay, this one. This one. So, okay, we do this exercise. Okay, this exercise first Mana tadi? This one example 7 Okay. Okay, remember by partial fraction. Hai, belum apa-apa dah mengeluh payah. Okay, partial fraction Okay, of course partial fraction for Fourier transform will not be that difficult as control subject Okay. Alright, so basically, okay, the question asks, use convolution property to find Fourier transform of the system output y omega for the following input and system impulse response. So basically, they give you xt, okay, and ht. So they ask you to find what is output in frequency and in frequency domain only, okay, which is y omega. So basically, what you're going to refer to is one of the table that you're going to refer is this one in appendix. So later we try to do it. We are going to do it for compare it. Why we want to use that table. So first, okay, let's understand the question because I'm afraid that some students when they don't understand the question, then they cannot get what is y. Okay. So the question is, you are given xt and ht. Where is xt and ht? Okay, if you have a block diagram like this, okay, ht is this one, ht, the impulse response. Xt is the input, which is xt. So the question asks, find the Fourier transform of the system output. So where's the output? Is over here, yt. So when you read question, try to imagine it and try to draw it out so that you don't make mistakes. Okay, and because the question say ask you guys, okay, find it in y omega, basically in frequency domain. Okay, so basically they don't want you to get it in time domain. Time domain will be using convolution integral. Okay, so they ask you to find in y omega. So because you learn in this chapter Fourier transform, then you are going to use Fourier transform table directly. Okay, so first step to solve this is write out the equation. Okay, based on what you have written based on the question. So we want to get y output. So y omega equal to ht times x omega in frequency domain. Okay, so and in the question you are given xt. So basically you are given this one, right, in terms of ht and xt. So from what I explained just now, if you want to convert it from time domain to frequency domain, you need to use the Fourier transform table. So let's look at the first equation for xt. So xt is given by 3e minus t ut. Okay, and ht is given by 2 E minus 2t ut. Okay. Meaning that you need to refer to the Fourier transform table. So go and look to the table. Where is the similar equation? The first one, right? This one. E minus AT ut. Right? Means that A is the value lah given. So the x omega, the Fourier transform is given by 1 over A plus j omega. So write it first. Okay, so I already written there. But anyway, I will write it again. Macam tak sempat lah. I don't think we have enough time lah. Okay, so sambung esok. Online. Tak apalah, we continue on Monday. Enough lah. Senior system for this week. 4 times enough So we meet again on Monday. On Monday 11 a.m. Okay, we continue this. I'm going to open this directly. We continue Okay, and then we do a bit of exercises before we continue with the circuit analysis. Okay, so that will be all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.